this. So back with the next sheet, we have more complicated equations. These ones are going to require a little bit of tracking, maybe a little bit of math on your point, just because there's more elements that are going on in there. Usually you're going to have to do this with equations where oxygen and hydrogen is present, because that can, due to the exchange of electrons that oxygen and hydrogen creates in equations, make them a little bit more complicated. And for the most part, you can keep the polyatomic ions together unless it's obvious that the polyatomic ion is kind of like falling apart, which is certainly possible, which we'll see in the second problem here. So this first one here is actually the equation that I talked about in the previous video about the production of lead paint. And this right here, lead iodide, is a salt that's bright yellow. And it's very strikingly yellow. It's something that we were going to make a little bit, probably around now actually we'd be doing this lab, but we'll get back to it, I hope, when we come back. The way we create this is basically we make a salt of lead nitrate. Now lead nitrate is completely soluble in water, so you can dissolve it in just like any other salt. And when we introduce potassium iodide to this, which is another salt, so salt plus salt, which you'll notice with double displacement reactions, generally it's an ionic compound reacting with another ionic compound and just creating two different ionic compounds. Now when you react this, what happens is the nitrate decides, hey, I'd rather be with that potassium than with this lead, because this lead is, I don't know, maybe he's just really mean or something. I don't really know what the deal is, but nitrate is sick and tired of his stuff. So nitrate and potassium react to create potassium nitrate, which is just like lead nitrate, a very soluble salt. And you won't even notice that this product is created because it'll stay dissolved in water. But you will notice that when those two things get together, it leaves lead and iodide as the leftover ions, and they combine as well to form lead iodide. This is extremely insoluble, and when you mix these things together, you're basically going to see a yellow powder appear and completely emulsify in your water. And it's actually a really cool reaction. Hopefully we'll get a chance to do it when we get back. Now balancing the equation is going to be something else, because there's a lot of stuff going on here. We've got 1, 2, 3, 4, 5 different atoms on both sides of this equation. The first thing I notice is that nitrate is on the left and on the right. So I'm going to keep the nitrates together as I add up the different atoms we have on each side. Okay, and then the other things I have are lead, potassium, and iodine. Lead, potassium, and iodine. All right. Before I start balancing the equation, I'm going to count how many of each I have on each side, just in case. You never know. Maybe it's already balanced. So I got 1 lead here. I got 2 nitrates, 1 potassium, and 1 iodine. Okay, let's see what happens here. Okay, I've only got 1 nitrate on the right. I've got 1 lead. Well, that's good. I've got 1 potassium, and I've got 2 iodine. So I've got a little bit of work to do here. I got my nitrate number isn't quite right yet, and my iodine number isn't quite right yet, and, you know, maybe these will stay 1, maybe they won't. We'll find out soon. All right, so basically, as I said, you want to leave the oxygens to the end. Now, since the oxygen's on a polyatomic, you can kind of ignore that one for this situation. It's more in this one, we're going to have to count the oxygen separate, where that's going to be a handy way to do it. So, let's see. I'm going to start with the nitrates here. I've got 2 nitrates on this side, 1 nitrate on this side, so I'm going to put a 2 in front of KNO3. That's going to double my nitrates to 2. Okay, there we go. You can really record this however you like as you go. You know, some people like to put an X through their number and put the next one just to keep a running tally of what they have. That way it's easier to undo mistakes. But that also means I have 2 potassiums. Now that's annoying. So now I've got 2 potassiums over here. That means I'm going to need 2 potassiums over here as well. So I better put a 2 in front of that. Alright, so that means I'm going to have 2 potassiums instead of 1, and I'm going to have 2 iodines instead of 1. And oh my gosh, look at that. 2, 1, 2, 2, 2, 1, 2, 2. And there are my coefficients. If you like, you can put 1s in front of the ones that don't have anything. Just because that shows me that that there's only one of those, but that's not necessary. It's like putting a 1 in front of X. It's redundant. So do it if you want. I'm really going to be looking for that 2 and that 2 when I ask you a question like this on a quiz or test. All right, next. Here we have the decomposition of sodium chlorate. Now, sodium chlorate is decomposing into sodium chloride, which is just table salt, and oxygen. Now, this leaves kind of an interesting dilemma for us to look at. ClO3 is definitely a polyatomic ion, but it's not ClO3 over here. So I'm going to actually record all 3 of these atoms separately. There's sodium, there's chlorine, there's oxygen. And if we count them, we're going to find there's 1 sodium, 1 chlorine. Oh, I don't need a little 2 on there. And 3 oxygens. And over here, there's 1 sodium, 1 chlorine, and 2 oxygens. Now, there's lots of ways to do this problem. The oxygens are the only issue. And I said up here that to include oxygen and hydrogen last. But interestingly enough, you'll notice that that's all that hasn't been balanced, right? The sodiums are good, the chlorines are good, it's just the oxygen. And the problem is, I got to get a 2 to a 3, and that's pretty weird, right? Because I can't just like add part of an oxygen, can I? Well, I have news for you. Your coefficients can be fractions if you want. Any fraction you like. Because the coefficients that are in front of here are just ratios of how many particles of this are required to make how many particles of this and how many particles of that. And ratios doesn't matter if it's fractions or not because they're only there to be compared. So I have to figure out what can I multiply 2 by to turn it into 3. And the answer is 1.5 or 3 over 2. And you're fine to put a 3 over 2 right there if you like. Personally, and that's going to change that into a 3 because 3 halves of 2 is 3. Now, it's not incorrect to leave fractions inside your equations, but it's actually better to do chemical equations without fractions by simplifying the fraction at the end in the same way you would in math. Basically, if I want to get rid of that 2 there, if I multiply everything in the equation by 2, that's going to cause the 2 to cancel out, right? So basically, if I multiply everything by 2, that means I got 2 sodium chlorates. Now I've got 2 NaCl's, and because I multiplied this by 2, it cancels out with the 2 underneath and leaves me with 3 O2s. So that 3 is now my coefficient as long as I put those 2's here and here. As I said, you're fine just to leave this 3 over 2. It's not incorrect. It's just, I guess, standard operating procedure to not include them. Now the last one we're going to do is a combustion reaction. And this is a good one because combustion reactions have hydrogens and oxygens, and balancing them can be kind of complicated because you have it's basically like a complicated single double displacement combo kind of reaction. There's a lot of stuff going on here. So once you see combustion reaction, first thing you want to do is start writing down your numbers for both sides of the equation. You might have a lot of work cut out for you when you do one of these. Kind of depends on what numbers they are. Now CH8H18, this is octane. So this is actually the reaction that's going on in the engine of your car that you're not going into because no one's going anywhere, and going to to get your car to go places. Now let's count them up here. I've got 8 carbons, I've got 18 hydrogens, and I've got 2 oxygens. On the right side, much simpler here. I've got 1 carbon, I've got 2 hydrogens, and I've got 1, 2, 3 total oxygens. Now this is where things get kind of weird because on the right side of the equation, you've got oxygen in 2 places. And if I put a coefficient in front of here, that's going to multiply the oxygens by that number here. But if I put a coefficient in front of here, it's going to multiply that by that number times 2, because each plus 1 I put here is going to give me 2 more oxygens, which is basically, I'm a long way away from being done. But remember my first tip, do hydrogen and oxygen last, right? Because sometimes hydrogen and oxygen just balances themselves out for you. And this is one of those cases where dealing with the carbon first is going to make this question much easier. Carbon, there's only 8 over here, there's only 1 over here, so I'm going to have to put an 8 in front of CO2. And that's going to get my numbers a whole lot closer than they were before, especially with carbon here. Now I've got 8 carbons. 8 times 2 is 16 oxygens. That's a lot of oxygens. All right. My carbons are balanced now, but my hydrogens and my oxygens are not. The next thing I'm going to do is my hydrogens. That is a common thing with these. I'd say do hydrogens and oxygens first. Generally, do oxygen last if you have to pick. You can do the oxygens first if you like by multiplying the 2 here by 8 to get to 16. But then you're going to have to go back and do hydrogens. And as you can see, that's going to mess up your oxygen numbers again. So you don't want to have to get stuck in like an infinite loop of changing the waters, going back, changing the oxygens here, and then you just keep going crazy with stuff. So instead, let's just do the hydrogens first. I got 2 hydrogens on the right. I got 18 hydrogens on the left. So I'm going to need 9 waters. That's going to multiply the hydrogens by 9. So now I've got 18. But the other thing you'll notice is it's going to also add, let's see, a whole bunch of oxygens to what I've got going on here. Now I've got 16 oxygens here and 9 oxygens here. So I'm stuck with and straddled with 25 oxygens on the right. That's pretty crazy. It's a lot of oxygens. But just like our last question here, we're going to be able to take this 2 and make it into 25 with just a simple fraction. Carbons and hydrogens are already balanced, so we're good to go. So that's my last question is what do I multiply 2 by to get to 25? Right? 225. That is annoying, isn't it? So, let's see. Just like up here, we had a 3 halves. Because what did I multiply 2 by to get to 3? Well, look, the number I wanted over 2. Same deal here. What am I going to multiply 2 by to get 25? Well, the number I want, 25, over 2. And as I said, you are perfectly fine to just stop right here. That is completely correct. I would give you full marks for that answer. But if you want to multiply everything by 2, it's certainly not a bad... I need to remind myself to look at the page when I write instead of the screen. That'll be 25 oxygens. And then there'll be 16 carbon dioxides and 18 waters. Okay. It's technically the more simplified equation. As I said, this is like probably more right if you're in university or college or something doing stuff. Your profs might really expect you to be able to simplify those equations. So it's not a bad idea to get into the habit now. But even they'll admit that technically fractions aren't wrong in an equation because it's a ratio, not a specific number. Plus, anyway, look at that. Each oxygen is made of 2 oxygen atoms. So if we think about it, 25 over 2 is kind of like 25 halves of oxygen particles, right? And since each oxygen particle is 2 atoms, then 25 halves of 2 atoms is 25 atoms. Which is, hey, what we have on that side anyway. I hope that was helpful for you. You'll notice in the folder as well, there is a Word document with a bunch of links in it. There's tons of extra questions you can get for this online, and your quiz at the end of the week is definitely going to be on identifying equation types and balancing equations. So do as much practice as you can or as you feel like, and once you're ready, you feel comfortable and confident, drop me an email, ask me for the quiz, and I will send you a copy. You can complete it on a piece of paper, take a picture with your cell phone, scan it into the computer, whatever works for you, and send me a copy of that.